All right, section 6-6, trapezoids and kites. So an isosceles triangle always has two congruent sides. An equilateral triangle is also an isosceles triangle. Cross out the lengths that cannot be the sides of isosceles triangles, and that's a 3, 4, 5 triangle. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides of a trapezoid are called the bases. The non-parallel sides are called the legs. The two angles that share a base of a trapezoid are called the base angles. So cross out the figure that is not a trapezoid. That would be this one. Circle the figures that can be divided into two trapezoids, then divide each figure you circled into two trapezoids. So this can be divided if I put a line here. And then this can be divided if I put a line here. So theorem 6, 19, 20, and 21. If a quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent. And 20, if a quadrilateral is an isosceles trapezoid, then its diagonals are congruent. So if trap is an isosceles trapezoid with base RA and TP, then we know angle T is congruent to angle P, and angle R is congruent to angle A. So use theorem 619, and your answer is 6 to draw congruence marks. So T is congruent to P, and R is congruent to A. All right, if ABCD is isosceles trapezoid, then AC must be congruent to BD. If ABCD is an isosceles trapezoid and AB equals 5 centimeters, then CD equals 5 centimeters. All right, so we're going to plug those in. All right. And then we also can plug in these. Here's that diagonal, and here's this diagonal. And we know both of these are congruent. Okay. So if a quadrilateral is a trapezoid, then we also know that the midsegments is parallel to the bases, and the length of midsegments half the sum of the lengths of the bases. So if trap is a trapezoid with midsegment MN, then MN is parallel to TP, which is parallel to RA. So MN is equal to half the sum of the bases. All right, so a fan has 15 angles meeting at the center. What are the measures of the base angles of the congruent isosceles trapezoids in the second ring? Okay, so circle the number of isosceles triangles in each wedge. Underline the number of isosceles trapezoids in each wedge. So there are 3 triangles and 2 trapezoids. So A must equal 360 divided by 15, which equals 24. B must equal 180 minus 24 divided by 2, which equals 78. C equals 180 minus 78, which equals 102. And D equals 180 minus 102, which equals 78. So the measures of the base angles of the isosceles trapezoid are 102 and 78. All right. So let's use somewhat of a proof here. Why can I say MN is equal to half the sum of the bases? Well, that's called the trapezoid midsegment theorem. All right, so substituting in the values from the trapezoid. Okay, simplifying what I have. Using a distributive property. Adding 1 to both sides. Subtract 2x from each side. And then divide each side by 2. So MN equals 2x plus 11, which equals 2 times 6 plus 11, which equals 12 plus 11, which equals 23. So a kite is a quadrilateral with two pairs of consecutive sides congruent and no opposite sides congruent. So if a quadrilateral is a kite, then its diagonals are perpendicular. So if ABCD is a kite, then we know AC is perpendicular to BD. Use theorem 620 and exercise 20 to draw the congruence marks. So we know these sides are congruent, these sides are congruent, and we have perpendicular segment there. Okay. Quadrilateral KLMN is a kite. What are measures of angles 1, 2, and 3? So diagonals of a kite are perpendicular, so measure of angle 1 equals 90 degrees. We know triangle KNM is congruent to triangle KLM by SSS. So measure of angle 3 equals measure of NKM, which equals 36. So 2 equals 1 minus 3 by the triangle exterior angle theorem. So we're going to solve for angle 2. So measure of angle 2 then has to equal 90 minus 36, which equals 54. Okay, so let's place a check mark in the box that fits the description. Place it next if it does not. So how is a kite similar to a rhombus, and how is it different? So is a kite a rhombus? Is a quadrilateral a rhombus? They are both quadrilaterals. Perpendicular diagonals. They both have perpendicular diagonals. Each diagonal bisects a pair of opposite angles. Just a rhombus. Congruent opposite sides. Just a rhombus. Two pairs of congruent consecutive sides. Just a kite and maybe the rhombus. Two pairs of congruent angles. And supplementary consecutive angles. Okay. So how is a kite similar to a rhombus and how is it different? Well, both quadrilaterals have perpendicular diagonals, two pairs of congruent consecutive sides, and one pair of congruent opposite angles. They are different because kites have no congruent opposite sides and only one pair of congruent opposite angles and no supplementary consecutive angles. And that's the end of the section.